Hello, I'm Brennan Campanelli, and I'll be demonstrating how to implement our jet engine analysis application using MATLAB version 2018b. The following was developed as a collaboration between myself, Matthew Yates, and Lauren Isaacson. Our code uses the thermodynamic analysis of each component, allowing you to easily optimize different jet engine configurations. Do note this does require you have MATLAB installed on your system. To begin, navigate to the URL shown. This will bring you to our GitHub repository where you can view the project files and read the program documentation. When you're ready to begin, click the clone or download button, followed by the download zip button. This will allow you to save the compressed project files locally on your system. When the downloads have finished, open your downloaded location and select to extract the files to wherever you wish. Navigate to the directory you extracted the files to in MATLAB. Here I extracted them to Downloads folder. Open the Project Files folder and you'll see several functions followed by a MATLAB app. Right-click the GUI app and select Run. After several seconds, you will see the main page of the application. From the first page of the application, you can see several editable fields, a drop-down menu, a dial, a switch, and several buttons. I'll go into greater detail about their operation in a moment, but for right now, let's hit Calculate for the demonstration. Now in the top left, you'll notice 4 tabs. Let's go to Constants, and you'll see values that you may not have to change all that often. For example, efficiency of the fan turbine, max temperature of the turbine, max temperature of the afterburner, fuel heating value, pressure of the fuel line, etc. Now come back up here and hit Visualization, and you can see several graphs and several editable fields. If we click one, these are automatically populated from the Initialization tab. Now if we change one, it will calculate and redisplay the graphs. This on the left you see specific thrust and thrust specific fuel consumption as a function of Mach number, and on the right you can see temperature and pressure across each component. For example, right here the output of the compressor is at 1000 degrees Kelvin. These graphs are also zoomable, so you can change the axes to get more accurate reading. All the way down you can see the axes change. Now if we come up to the last tab, the Results tab, you can see the output of the raw data in table format. You can see these are the inputs to the calculation and these are the outputs. You can see we're using a combined nozzle, so you can see the output of the velocity, pressure, and temperature. Notice this Calculate button only performs calculations with flight condition 1. Now let's say you don't know these values that you want to use or the fan and compressor pressure ratios. What you can do is enter this flight condition 2, and when you click Optimize, what that will do is it will use flight condition 1 and flight condition 2. It will meet those criterion as well as design constraints, and it will minimize the thrust specific fuel consumption and give you an output. Now, for example, let's change this to a long-range missile. What that does is it populates these fields with values that we determined earlier were giving us minimum thrust-specific fuel consumption while meeting the flight conditions according to the flight conditions given in the project. So when we select that, you can see it changed to turbojet, gave us several values, and it did not change the flight conditions. If we click Optimize, you can see it could not converge. That is because these flight conditions can't be met with a turbojet at the given constraints. So let's change these to the values given in the project. 6.25. You can notice when I click out of there, it automatically populates the temperature and pressure according to the International Standard Atmosphere models. Let's change the Mach number to 0.8 and the required specific thrust to 0.3. Let's change the altitude of flight condition 2 to 15.2, Mach number to 2.4, and the required specific thrust to 0.7. Now when we select optimize, it will vary these 4 variables as well as the fan and compressor pressure ratios using this engine type, this which does not matter for a turbojet. It will try to, so it will vary these 4 variables while trying to meet flight condition 1 and 2 and minimize the thrust specific fuel consumption. So we select that, you'll see this, and when it's done, it populates these values with the calculated optimums. And if you go to visualization, you can see the specific thrust and thrust specific fuel consumption as a function of Mach number all the way up to Mach 4, and the component temperature and pressure. In the results, you can also see the raw outputs. You can see a thermal efficiency, propulsive efficiency, overall efficiency. Do note, however, that while the Optimize button meets flight conditions 1 and 2, the output to the Results tab in the Visualization tab is only for flight condition 1, similar to the Calculate button. Now let's head back to the Initialization tab. You can see turbojet here. When that is selected, the fan bypass ratio is set to 0, and the fan pressure ratio is set to 1 because there is no fan on a turbojet. Now, let's say you want to keep the physical components of the engine the same, but you want to vary combustor fuel air ratio, the afterburner fuel air ratio, and the compressor bleed. What you do is you select maximize. What that will do is that will vary those 3 components while meeting flight condition 1 and maximizing the specific thrust. So it'll use this altitude, this Mach number, and it will maximize the specific thrust. So we just selected that, so let's head to visualization. You can see same data here. You can see zero bleed ratio for this maximum. Let's select, we can increase that a little bit just for fun. Now go to the results file. You can see we're operating close to Fmax, and you can see the overall efficiency went down, but the specific thrust at flight condition 1 went up quite a lot. Now when you're done using the application, all you have to do is select exit. When the code is run, it generates a results file, a temporary results file in the same directory as the application itself. If you want to delete it, select yes, and it will be deleted, and the application will be closed.